Good afternoon, everyone. In the last class, we discussed about software quality assurance, right? We already started software quality assurance. In software quality assurance, actually, what we assure the quality of the software, right? By software engineering process, methods, activities, and work items that we monitor. And we always check with standards, defined standards, right? So if the software which followed the standards, then we could say that software is a high quality software. So in software quality assurance plan is the plan contain what is the procedure you need to follow, what are the techniques, what are the tool you need to use to get a good quality software that part discussed. Then it contains what are the things: SQA process, specific quality assurance, effective software engineering practice, methods and tools, and software work products, compliance, measurement and recording mechanisms are part of software quality assurance. And there are some SQA activities that we discussed: creating an SQA management plan, set the checkpoints, apply software engineering techniques like FAST, SLOC, FP function points, and execute formal technical review to uncover the errors, and having multi-testing strategy and enforce the process adherence, control the change, and measure the change impact, and perform the SQA audits, maintain the records and reports, manage good relations, all are needed to prepare a software quality to get us good quality software. So all of these things are part of software quality assurance activities. So techniques, auditing, reviewing, code inspection actually is part we already completed. Just went through this once more to remember. Then elements are software engineering standards, audits, reviews, testing, error correction, error collection and analysis, change management, educational programs, vendor management, security, safety, risk management. So these are the elements and that to be discussed. Then the theory of these things, what I explained in the previous classes, is there as notes. Then SQA need, activity, task, goals, and metrics. SQA group review selected work products, identify the document and track the deviation, verify the corrections have been made, and periodically report the results of the work to the project manager. This is the total SQA, software quality assurance activities. You can explain in a single sentence like this. An SQA group, there is a team is there, software quality assurance team is there, that team review the selected work products which you made, and it identify, document, and track whatever deviations happened according to the standards, and verify the corrections what you made before, and it report the results to the project manager. This is the in a single sentence. If you define the software quality assurance, you define like this. So in the last class, actually, we discussed about statistical software quality assurance. In statistical quality assurance, actually, statistically, we are collecting and categorizing the information. So for that purpose, we are using Pareto principles that I explained, 80-20% rule, that is Pareto principle. Anyway, the software quality assurance main purpose is to to find out, trace the underlying cause, non-conformance to specification, design error, violation of standard, poor communication with the customer. So possible causes, these are the possible causes of defect in a software system. There are incomplete, erroneous specifications, maybe the intentional deviations from the specification. Suppose if you are not in harmony with your team members, you may do some revenges also. Sometimes it may happen, this deviation from specifications happen by chance. It's not an intentional thing. Then violation of programming standards, error in data representation, inconsistent component interface, errors in design logic, incomplete, erroneous testing, inaccurate, incomplete documentation, error in programming language translation, ambiguity, means different interpretation for a single term, that is ambiguous. So many things, these are the possible cause of defect of the system. So in the software quality assurance time, you should identify those defects and you should improve your product by removing or replacing your product. The next is Six Sigma. Sigma actually it's popularized by Motorola 1980. It's a strategy for statistical quality assurance. This is a strategy for statistical quality assurance. How can you achieve? This is Six Sigma is one of the strategies. A rigorous discipline methodology uses data and statistical analysis to measure and improve a company operational performance by identifying and eliminating defects in manufacturing and service-related processes. This is the single sentence explanation or definition for software Six Sigma. Six Sigma as a disciplined, rigorous methodology which uses data and analysis, statistically been analyzed for what? To measure and improve company operational performance. So the measurement and improvement, this is mainly in between analysis is there, but measure and improve a company's operational performance by identifying and eliminating defect in manufacturing and service-related processes. So it's actually refer to 6 standard deviations. 6 standard deviations means 3.4 defects per million occurrences. Means its accuracy is very high, 3.4 defects per million occurrences. So it's almost 99.9996%. That much quality means deviations from the standard only will be there. So it's a high quality product once you follow the Six Sigma. So the name Six Sigma was derived from bell curve. In statistics, you know how the bell curve comes. In that one, very slight deviation only from the where 1 sigma represents 1 standard deviation. So 6 sigma, 6 standard deviation, very small amount only. The defect rate is set to extremely low when it comes to Six Sigma. Six Sigma, actually, there are 5 principles. First is consistent and practical approach to reap the profitable results. To reap profitable results, we should follow some practical approach and consistent approach. Then involve a strong problem-solving team. We need a strong problem-solving team and eliminate the variation to improve the processes, data accuracy, which helps to find the root cause of the problem and focus on customer requirements. You need to focus on customers. So Six Sigma contains 5 principles. Consistent, practical approach to reap the profitable results, involves strong problem-solving team, eliminate variation to improve the process, data accuracy, focus. So you just remember these 5 points. Define, measure, analysis, improve, control. Define requirements. Define deliverable. Define the project goal before you start the project development or at the time of customer communication. And measure the existing process and output to determine current quality performance. You need to measure the existing product process. The next you need to analyze. Suppose if you find out any defects, you have to analyze defect metrics and determine the causes. That is the third point. Then there are two more additional steps, that is improve and control. Improve the process by eliminate the root cause and control the process to ensure future work doesn't introduce the causes of defects. You already cleared. So these are the 5 points you need to remember. DMAIC. DMAIC means define, measure, analyze, improve, and control. This is used for an existing product. If an existing product having some defects, you can use this DMAIC methodology. It first define the problem, then quantify that problem or measure or metric the problem. Then it analyze or identify the cause of that problem and implement and verify solution, maintain the solution. So these are the Six Sigma DMAIC for an existing product. When it comes to a new product, okay, new product, DMADV. DMADV means define, measure, analyze, design, and verify. So that is DMADV or DFSS. Other name is DFSS, means design for Six Sigma. DMAIC means first you need to define the goal, and you can help to improve the process which sync with the strategy and customer need. Every enterprise has its own strategy and should sync with both enterprise strategy and the customer need to improve the process for that. That is define your goal first. Then measure the aspect of ongoing process and accumulate data that's relevant to that. The next is analyze the data. Data you need to analyze, which is circulating, and then verify it. Once it's done, analyzing involve determining the relationships and attempting to ensure that every factor has been taken into consideration that you need to make sure. That is the data analysis. You should consider every factor. You should consider every characteristics. Based on that, you have to define that. The next is improve the process of data analysis. With help of new techniques, you can improve it and control in order to check, means verification, last is verification. So DMAIC. DMAIC is define, measure, analyze, improve, and control. DMADV and DMAIC. So that represented in form of diagram, and some companies which are following, Wipro, Sears, Motorola, Ford Motor Company, then Boeing, Amazon. Some companies names are familiar to you. All these companies actually they are following this Six Sigma. So before coming to that, I will show you, going to the next topic, I will show you one small video which represents the whole concept related to the Six Sigma. The concept will be more clear. So listen to the video. Are you listening? Students, are you there?
Yes, ma'am.
Okay. Yes, ma'am.
Then I will play one video which is explaining all the concepts related to this Six Sigma, both DMAIC and DMADV methodologies. So listen this video.
Okay, ma'am.
Imagine you've been tasked with a really important project.
Can you hear the sound?
Yes, ma'am.
Project at work. The company you're working for produces luxury cars. The production numbers are going down, and a lesser number of cars are getting manufactured each day. There also seems to be an issue with the quality of the windshield wipers that go on these cars. The question you are faced with: is there a way for the company to stop the stall in production and increase the production per day from 1,000 to 2,000? Also, is there a way to find out what's causing the drop in the wiper quality? There is. Six Sigma. Six Sigma gives you the tools and techniques to determine what's making the manufacturing process slow down, how you can eliminate the delays, improve the process, and fix further issues along the way. The concept was introduced in 1980 by Bill Smith while working for Motorola. Since then, Six Sigma has seen worldwide adoption. Six Sigma aims to reduce the time, defects, and variability experienced by processes in an organization. Thanks to Six Sigma, you can produce a defect-free product 99.9996% of the time, allowing only 3.4 errors per 1 million opportunities. Six Sigma also increases customer loyalty towards the brand, improves employee morale, leading to higher productivity. Six Sigma has two major methodologies: DMAIC and DMADV. Let's look at the first methodology. DMAIC is an acronym for Define, Measure, Analyze, Improve, and Control. Let's have a look at each of these stages individually and how it relates to your earlier problem. In the Define phase, you determine what issues you're facing, what your opportunities for improvement are, and what the customer requires of you. Here, you look at the process as a whole and determine the issues with the manufacturing process. In this case, finding out why the cars had varying windshield wiper quality and how to optimize the current process to manufacture more cars. In the Measure phase, you determine how the process is performing currently in its unaltered state. You determine the current number of cars that are manufactured in a day. In the current scenario, 1,000 cars are manufactured in a day, and each of these cars are outfitted with a pair of windshield wipers by one of 30 machines used. Some of the metrics measured are how many cars are produced in a day, time taken to assemble a car, how many windshield wipers were attached in a day, time that takes them to do so, defects detected from each machine on assembly completion, and so on. Following this, in the Analyze phase, you determine what caused the defect or variation. On analyzing previous data, you find out that one of the machines that installed the windshield wiper was not performing as well as it was supposed to. Production was taking longer since the car chassis was being moved across the different locations slower, as cranes had to individually pick and drop the frame. This was because the wheels were attached to the car only in the last stage. Next, in the Improve phase, you make changes to the manufacturing process and ensure the defects are addressed. You replace the faulty machines that installed the windshield wiper with another one. You also find a way to save time by attaching wheels on the frame in the initial stages of the manufacturing process, unlike how it was done earlier. Now the car can be moved across the assembly area faster. And finally, in the Control phase, you make regular adjustments to control new processes and future performance. Based on the changes made, the company was able to reduce production time and manufacture about 2,000 cars a day with a higher quality of output. DMAIC is one of the most commonly used methodologies in the world.
Okay, this is the first methodology, DMAIC. Did you understand the example which I explained? This is an example of how to implement, how to use the DMAIC. Here, they consider one automobile industry where the number of production, they noticed two problems. One is reduce in number of productions, and another is a faulty windshield wiper. So these two, but not for every car, but 1 out of 30 cars are experiencing that problem. And total production is going down. So these are the two problems they identified. First, so they have to define the problem. What is the determine? So steps are given, right? What issue now you are facing, that you have to determine, and what are the opportunities for improvement that you need to understand, and you have to consider what are the customer requirements. So that is the first part, defining. The second part is measurement. You have to measure some things like how many cars you are producing per day, and how many faulty windshield cards you are producing per day. So that you have to measure, and some other factors which is related to this metrics you need to identify. The next is analysis. The analyzing time, you should identify why this 1 out of 30 cars, only one car is getting damaged. What is the reason? That you have to find out. The another thing is why my assembly section is slow. These are the two problems you need to analyze. So at the time, you could find out some reasons. Like, for example, in 1 out of 30, windshield wipers at faulty means the assembling of those assembling machines for those windshield wipers were not correct. So if you identify, then you can replace. A replacement is coming in the next phase, actually improvement phase. Only you are analyzing the problem. At the time, you may find out something, okay, this particular assembling machine is not working properly. So that is the thing you identify during the analysis time. The next is, it's slow process, because you are using one crane like things to move your this car from one place to another for assembly. Instead of that, if you put wheels before itself, you can move easily from one place to another. So that also you can, these two reasons you analyzed, the problems you analyzed. So in the next phase, actually you are acting solutions, means you are giving some solutions, like you're improving your product. How can you improve the product? You can assemble, okay, you can suggest assembling of wheels you can done in the previous phase. So now you need to wait for the last stage. So then I can save some time. Means while shifting car from one place to another place, it takes a lot of time comparing to if you connect wheels. You can move from one place to another. The next thing is, you can replace the faulty machine, assembling machine, and with a new one. So these two are the improvement part. And controlling means you should already you find out the reason and you rectify the problems by replacing with the first one, replacing with a new machine, and second problem you solved by rearranging the order of assembly, by assembling the wheels before stage itself. So after that, in controlling time, you are analyzing. Now, what is based on the changes made, you have to analyze it again. Then you can understand the changes made a good impact on your system, like the entire production is changed from 1,000 to 2,000 per day. And now the faulty windshield assembling is not there because the new machine I replaced with new machine. So that problem also solved. So at last, when you go for a customer feedback, definitely you will get a customer satisfaction. Means 5-star, it's showing it like, means like, or the customer feedback is good. So these are the different stages of this methodology: define, measure, analyze, improve, and control. That explains very simple example. Did you understand this? This is for an existing system. This DMA IC we are applying for an existing system because already one industry is running and then you are analyzing. So when comes to next methodology,
it focuses on improving the existing products of the organization. The second methodology is DMADV, which is short for Define, Measure, Analyze, Design, and Verify. It is used when the company has to create a new product or service from scratch. It is also called DFSS, or Design for Six Sigma. Let's take the scenario where the company decides to build a new model, a sports car. In the define phase, you define the requirements of the customer. Based on inputs from customers, historical data, industry research, you determine what you need to ensure your car becomes a success. The data collected indicates customers are drawn to cars which can achieve more than 150 miles per hour. Customers are also more inclined towards cars which have V6 engines and an aerodynamic frame. Then, in the measure phase, you use the customer's requirements to create a specification. This specification helps define the product in a measurable method, so that data can be collected and compared with specific requirements. Some of the major specifications that you focus on are the top speed, engine type, and type of frame. In the analyze phase, you analyze the product to determine whether there are better ways to achieve the desired results. Areas of improvement are determined and tested. Based on the analysis of the prototype created in this phase, you find that the product satisfies just about all of the customer requirements, except the top speed. So, research begins on an aluminum alloy that could possibly meet the speed requirements of the customer. Following this, the design phase. Based on the learnings from the analysis phase, the new process or product is designed. Revisions are made to the model, and the car is manufactured with the new material. The analysis phase is repeated based on the new design. You also bring a focus group and see how they receive it. Based on their feedback, further changes are made. And finally, in the verify phase, you check whether the end result meets or exceeds customer requirements. Once you launch your brand new sports car, you collect customer feedback and incorporate it into future designs. And guess what? Your customers are loving the new design. And that is DMADV for you. Six Sigma has also found success in a number of different industries. The petrochemical, healthcare, banking, government, and software are some of the industries that have utilized the concepts of Six Sigma to achieve their business goals. Another commonly used methodology adopted by companies around the world is Lean. Lean is a methodology that aims to remove any part of the process that does not bring value to the customer. It means doing more with less while doing it better. The philosophy behind Lean comes from the Japanese manufacturing industry by Bob Hartman, who at the time was part of Toyota. Since then, across the world, services and manufacturing organizations have incorporated Lean within their businesses. But what if you could have the best of both worlds? A combination of both Six Sigma and Lean. That's Lean Six Sigma. Before we get into Lean Six Sigma, we've got a quiz for you. What methodology is used by companies when they want to release a new product created from scratch? A. Design, measure, analyze, define, verify. B. Define, measure, analyze, design, verify. C. Demand, measure, analyze, improve, control. D. Define, measure, analyze, improve, control. Leave your answers in the comment section below.
Methodology is DMADV. This is for a new product which you are planning to launch, a new product in the market. You can adopt this methodology. Here, what are the methodology? DMADV. Design, measure, analyze, define, verify. Define, measure, analyze, design, verify. Demand, measure, analyze, improve, control. The last two are not. Then first two, which one? Define, measure, analyze, design, verify. Not define, verify. Design, verify. Because for designing purpose, we are using this methodology. When you are planning to launch a new product in the market, we can use this methodology, DMADV, as a part of Six Sigma, which we are using. Here, actually, an example given in that example. This is DMADV. In this example, actually, this is for a new product which is going to launch and service from scratch. These two cases we can use the DMADV. And it's also called DFSS. DFSS means Design for Six Sigma. And suppose if a company wants to build a sports car, first it should define what are the customer requirements, right? So customers obviously for sports car, they're expecting for a very top speed. So 150 miles per hour. That is not like that's top speed. There are three factors they consider, right? What are they? Customers. Anyway, customer requirements. What are the customer requirements that you need to measure? Top speed, engine, and type of the frame. So these are the three things, specifications that once you collect the customer requirements, you have to sort what are the major things customer required for a sports car. So suppose if it is a top speed, engine, and type of frame, they are very much bothered about this three things. So then you concentrate on those three things, and you should identify the area of improvement that determined and raised in the analysis phase. So how can you achieve the top speed? The remaining two things you already identify. How can you achieve a good top speed? And not top speed is not the then engine engine type and type of frame. Type of frame, what type of material you need to for frame or structure. What is the preference of the customer that you have to analyze during the analysis phase. But coming to top speed, how can you change the speed? So that you should learn again. And here they change the material, right? So they change the material to improve the top speed. Then the results, once you fit all these things in your sports car, you have to check the customer requirements. Then probably they will be happy with your new production. Like you concentrated these three things, which is very important. You feel from the customer review, right? So you concentrated more on these three requirements, and you try to rectify the customer. Not rectification. It's a kind of customer requirement. You satisfied the customer requirements by improving these three things. One is a top speed, another is engine, and another is type of frame. So you consider, you change the material, you change the production style, you change the you achieve the top speed by changing the material, right? So at last you will get a good quality.
Result meets or exceeds customer requirements. The new material. The analysis just about all of the customer requirements, except the top speed. So, research begins on an aluminum alloy that could possibly meet the speed requirements.
They change the material using aluminum alloy, right?
So the customer. Following this, the design phase. Based on the learnings from the analysis phase, the new process or product is designed. Revisions are made to the model, and the car is manufactured with the new material. The analysis phase is repeated based on the new design. You also bring a focus group and see how they receive it.
The new production, you have to take the customer requirements, means customer feedback. Then the customer, whether they are satisfied, probably they'll be happy. Because here you worked mainly based on the customer requirements. So the new product, basically, you work to satisfy the customer requirements, not like the previous one. Previous one, for identifying the existing product defects and how to recover, how to that analysis comes from for the defects recovery. This one for a new product, so have to match with the customer requirements. So this one, yeah, I can apply in the design phase for a new product. So these are the two methodologies you should remember where you can apply the Six Sigma. One for a product which is existing when it has experiencing some kind of defects or less productivity. There are many factors you can consider, but only for the existing one. This one for a new product, which is going to launch a new product, you can apply this one for the new design. So don't get confused with these two methodologies. Is it clear to everyone? These two methodologies, DMAIC and DMADV. Is it clear or not? Shall I repeat it again? Six Sigma. For one person, it's clear.
Clear, ma'am.
So don't get confusion. Next is these are some companies which already implemented using this methodologies. Next is ISO 9000 quality standard. Actually, in your syllabus, the general describes ISO 9000. They are not explaining about, they're not asking for any, actually ISO 9000 is the basic one. There are different classifications are there, and that is not mentioned in your syllabus. So I simply explain what is 9000 quality standard. Actually, quality standards contain some guidelines and standards. Okay, that standard you need to follow when you are preparing one new product. At the time, you should ensure the quality planning, quality control, quality assurance, quality improvement, everything. Some guidelines are clearly mentioned in the standard, so you should follow that. So when it comes to 9126, actually, it's not. I think it's not there in your syllabus. There are some. I'll leave it that. If it would be there, I will explain. Then general inspection. General inspection actually are doing with the help of checklist. Here we should check each and everything in your software design. The design is already done. You have to check with some in checklist containing the areas which you need to cover. So general requirements and design, functional interface specifications, conventions, requirement traceability, structures and interfaces, logic, performance, error handling recovery, testability, extensibility, coupling coefficient. All this area will be clearly mentioned in the checklist. With the checklist, you have to check your design. Okay, so that is called a design inspection. Inspection means you have, these all comes under that: training, servicing, statistical techniques, control of quality, storage, packaging, correction, prevention. All things comes under inspection, because we are checking these areas with your design. Actually, checklist contain all. Why we are going for checklist? We should not avoid a single area. That's why we are going for checklist. First, we should prepare one checklist. Otherwise, we may miss some important areas. Then elements. Elements actually standards, reviews and audit, testing, error, defect collection analysis, change management, education, vendor management. Actually, I completed this part, right? Do you remember? This elements of software quality assurance. Standards, means like ISO, ISI, IEEE, many standards, organization standards are there. You should follow those standards. Then review and audits means frequent reviews should be needed to uncover the errors. And there are some guidelines you need to follow. Whether you are following those guidelines, it's checking in the auditing section. And testing you have to done very frequently for not only one testing, multiple test methodology you need to choose to identify the errors in an early stage. And you should at the time you should identify the errors or defects. You should collect those things and you should prepare the strategy, and you should analyze to recover from that, how to eliminate those defects. Then change management, when you make some changes or modification in your project, source for a system, how it adversely affected. Is it making any other problems too, that you need to check. And when you make some changes with the customer requirements, again you have to check the new modified system. And education means you have to improve you have to adopt new engineering practices, methodologies, and tools. You should train your engineers and managers. Okay. Then security management, because of different types of cyber crimes, new regulations, government regulations make come, right? So that you need to, that policies you should discuss. Security management is also important. So how can we give more security to our software? That you should ensure that the software has not been tampered with internally, and you should be aware about the new government policies for these cyber crimes related things, and you should educate your people. Then safety. Safety means both hardware and software failure and their impact study you need to do to reduce the risk. The risk analysis, that we call risk analysis, and each and every risk has different types of impact. Some are moderate, some are creating very big problem in your system, and some are you can ignore some impacts. So different types of risk are there. So you should analyze the risk and categorize it, and based on the impact factor, you have to concentrate more on the highly dangerous, means highly some risk which affect your system very badly, severely. So you should concentrate more on those, and you should try to recover from that. So SQA may be responsible for assessing the impact of software failure and for initialize those steps required to reduce the risk. Risk analysis always, because everywhere you should try to give the priority based on the impact factor. And not only the impact factor, the frequency also you need to consider how frequently that particular risk is coming. If the impact, when you give the higher priority, the impact factor is more and it's coming very frequently, you should give higher priority. If the impact factor is more but it's very less, it's not happen, then you can consider it as a moderate. If the impact factor is less and it's not happening, and then you can simply ignore those type of risk. That risk management is there. That is called risk management. So based on that, you can create some contingency plans. That is proactive and reactive risks are there. Proactive means with your experience, you can learn some type of risk may happen in your system. That for that type of risk, you can create a contingency plan that is called proactive risk. And suppose if that particular risk may happen in my system, how can I eliminate? How can I recover from that risk? That strategy you can make before itself. That's called proactive type of risk, proactive risk strategy. And coming to reactive means, so you are not even aware about what kind of risk may happen. At the time, immediately you should take decisions to come out of that risk. So that is reactive. So risk management contains both types of risk. You should be able to handle both types of risk. Next today I will discuss about software reliability, and we have two more topics: software reliability and I think software quality plan also there. Yeah. Software quality plan, SQA plan, and these are the two. 1 second. Software ISO 9000. Once I have to check in your textbook what are the points covered in ISO 9000. Even 9126 quality standard actually comes under 9000 only. So what are the different classification I need to discuss that. I will check once and I'll explain. And SQA plan and reliability. These two parts, two points, then we can complete the module 4. So next week, probably we have one more test. So any other doubts? Any other doubts regarding today's topic? Can I stop? Okay, no response. So I'm going to invite.